Coronaviruses are a large family of enveloped RNA viruses. There are 4 groups of coronaviruses: alpha and beta, originated from bats and rodents, and gamma and delta, originated from avian species. Coronaviruses are responsible for a wide range of diseases in many animals, including livestock and pets. In humans, they were thought to cause mild, self-limiting respiratory infections until 2002, when a beta coronavirus crossed species barriers from bats to a mammalian host before jumping to humans, causing the severe acute respiratory syndrome SARS epidemic. More recently, another beta coronavirus is responsible for the serious Middle East respiratory syndrome, MERS, started in 2012. The novel coronavirus responsible for the coronavirus disease 2019 pandemic, COVID-19, is also a beta coronavirus. The genome of the virus is fully sequenced and appears to be most similar to a strain in bats, suggesting that it also originated from bats. The virus is also very similar to the SARS coronavirus and is therefore named SARS coronavirus 2, SARS-CoV-2. At the moment, it's not yet clear if the virus jumped directly from bats to humans or if there is a mammalian intermediate host. Coronavirus genome is a large, single-stranded, positive-sense RNA molecule that contains all information necessary for the making of viral components. The RNA is coated with structural proteins, forming a complex known as nucleocapsid. The nucleocapsid is enclosed in an envelope, which is basically a lipid membrane with embedded proteins. From the envelope, club-like spikes emanate, giving the appearance of a crown. This is where the corona name came from. The integrity of the envelope is essential for viral infection and is the Achilles heel of the virus because the lipid membrane can easily be destroyed by lipid solvents, such as detergents, alcohol, and some disinfectants. In fact, enveloped viruses are the easiest to inactivate when they are outside a host. In order to infect a host cell, the spikes of the virus must bind to a molecule on the cell surface, called a receptor. The specificity of this binding explains why viruses are usually species-specific. They have receptors in certain species and not others. Host jumping is usually triggered by mutations in spike proteins, which change them in a way that they can now bind to a receptor in a new species. The novel coronavirus appears to use the same receptor as SARS coronavirus for entry to human cells, and that receptor is the angiotensin-converting enzyme 2, ACE2. Infection usually starts with the cells of the respiratory mucosa, then spreads to epithelial cells of alveoli in the lungs. Receptor binding is followed by fusion of the viral membrane with the host membrane, and the release of nucleocapsid into the cell. The virus then uses the host machinery to replicate, producing viral RNAs and proteins. These are then assembled into new viral particles called virions. The new virions are released and the host cell dies. Uncontrolled growth of the virus destroys respiratory tissues, producing symptoms. Infection triggers the body's inflammatory response, which brings immune cells to the site to fight the virus. While inflammation is an important defense mechanism, it may become excessive and cause damage to the body's own tissues, contributing to the severity of the disease. In an otherwise healthy person, there is a good chance that the virus is eventually eliminated and the patient recovers, although some may require supportive treatments. On the other hand, people with weakened immune systems or underlying chronic diseases.
Welcome to 5 Minute School. You may have heard in the news a man in China died from an infection with a virus known as hantavirus. Yes, you heard different. There is another virus on the agenda. So this virus originates from rodents like rats who are hosts to the virus. The virus is also contained inside the feces and urine of the rodent, even in the saliva. And if the virus becomes airborne, it can be inhaled by a human and result in infection. The virus can also enter through open wounds and also through bites. The symptoms of hantavirus include fever, muscle aches, which occur mainly in the large muscle groups, for example the thighs or the back, Fatigue is also a common symptom alongside nausea, diarrhea, and abdominal pain. At a later stage, at around 4 to 10 days of infection, symptoms of hantavirus pulmonary syndrome may occur, which includes coughing, shortness of breath, and fluid filling up the lungs. Hantavirus pulmonary syndrome has a fatality rate of around 40%. There's no vaccination or cure for hantavirus at this stage except for management of symptoms. Hospital admission early on results in a better prognosis for the patient because with the cases of difficulty in breathing and the lung issues that it causes, having access to oxygen and a ventilator really assists with the respiratory distress. There's no human-to-human transmission of hantavirus at this stage. The main passage of infection is breathing in the infected feces particles when they're floating around in the air, or rodent bites, and eating foods which are contaminated with rodent droppings. Those who are at risk of hantavirus are those who have infested houses, campers or people living near foresty areas, and those in close proximity to the rodent population in their day-to-day lives.